Grade 12 Physics, Light Note number 7, The Wave Nature of Light Applications. In this note, we're going to look at something called thin film interference. So this is the interference pattern or the rainbow effect we might see when we're looking at a soap bubble, or if we're looking at an oil spill on the street. We can see along the fringe of that oil spill there's a rainbow, and that's produced from interference of light through a thin film. First, we need to review the reflection of waves off of a barrier. Let's remember that if we have a fixed barrier and we have an incoming crest, that crest is going to hit the barrier and be reflected as a trough. So we're going to get a phase change here. That crest is going to change its phase into a trough and be reflected. On the other hand, if we have an open end, so that's going to be denoted here as a loose end where that end can move up and down that wall barrier. Let's say here again we have an incoming crest. If that crest hits the wall and bounces back, it's going to bounce back as a crest. We have no phase change if we have an open end. So let's apply this to a thin film, something like a soap bubble. What we need to specify here is how thick that soap bubble is going to be. We're going to look at two thicknesses. The first one is going to be a thickness of 1/4 lambda. The second one will be a thickness of 1/2 lambda. So here's our 1/4 lambda thickness soap bubble. Let's look at a ray of light here, or a wave of light that's incident on that soap bubble. Some of that ray is going to be reflected off the top. When it's reflected, it acts as if that top was a fixed end, so we're going to get a 180-degree phase change in that wave. Part of that light, though, is going to be transmitted through that soap bubble barrier and bounce off the interior of that soap bubble. When it bounces off the interior, it acts as an open end, and we don't get a phase change. When it reflects off that interior, it leaves the soap bubble through the top then. We notice that the two waves here constructively interfere. So let's say red light was incident on the soap bubble. If the thickness of the soap bubble was 1/4 of the lambda of red light, that red light will constructively interfere and will shine brightly on that soap bubble. Let's change the thickness here now though. The thickness now is going to be 1/2 lambda. This incident light again is going to hit off that top fixed end barrier, and we're going to get a 180-degree phase change as it bounces off. Again, part of it's also going to be transmitted and bounce off the second surface, or the inside surface of that soap bubble. Here it's going to act as an open end. When this ray leaves the soap bubble, we notice that it's completely out of phase with that initial ray that bounced off the top surface. In this case, we're going to get destructive interference. So let's say red light shines on a soap bubble that's 1/2 of a lambda. It's going to destructively interfere itself, and we won't see any red light shining off of that bubble.